All right, so our notes today are over matter. Exactly what is that? What's it have to do with chemistry, etc. Remember, everything we're going to do for the next couple of weeks is going to be over chemistry. So, chemistry basically is the study of matter. That's what we study. So, matter then is anything that has mass and takes up space. So, chemistry likes to study a whole bunch of stuff. Pretty much anything that you can think of that has mass and takes up space, chemistry is interested in knowing about, whether that's what it's made up of, etc. So we want to go through and kind of get some examples of things then that are matter. A wrench, obviously, is matter. It has mass, we could weigh it, and it takes up space. We can see a certain volume that it takes up. But there are some things that are not matter. For example, the heat or the light that we get from the sun is not matter. The sun itself, however, would be considered matter. The sun has mass and takes up space, but the heat and the light, etc., that we get from it is not matter. So then what do we do with this idea of matter and mass? Well, mass is simply the measurement of how much matter something contains. It's an amount of matter. Matter, on the other hand, refers to an object's composition. So we would say something like, oh, I have 5 grams of steel. Okay? That would be matter. If all I said was that I have 10 grams, well, that's just its mass. So we're looking at the difference here. This would just be the mass, and then this would be matter, because we refer to, again, the composition, the steel. Now that we know what the difference between matter and things that aren't matter and mass and matter, what do we do with it? How do we classify it? Well, the first thing you have to know is that all classifications are going to be based on observation. So we're going to input something that we see or observe or whatever, and then we're going to organize it into these nice groups. Well, what are our observations again? Remember, there's 2 types. This hopefully is reviewed from scientific method. There are quantitative observations, which is going to use numbers to measure qualities, and then there are qualitative observations, which are just things about the traits or characteristics. So something like it's 2 light years away. That's a quantitative observation. But if we said, let's say the object is yellow, that is a qualitative observation. Make sure again you know the difference between those 2. So now that we know how or what we're going to use to classify our matter, let's look at how we actually do this. Well, first of all, matter is going to be broken into 3 basic forms. You have elements, compounds, and mixtures. Okay? Elements are listed on the periodic table. So these right here are where we get all of our elements, and you'll get a copy of the periodic table probably in the next couple of days. Next, anything that we have a formula for, like this, where we start putting elements together, these are compounds. And then last, if it's got a whole bunch of stuff put together, we have a mixture. Okay? Elements, remember, are found on the periodic table. They have to be. If they're not on the periodic table, they're not elements. Compounds are then going to have multiple elements together in a certain way. Remember, we have a formula for them. Sugar can only be C12H22O11. Water can only be H2O. Salt can only be NaCl. That's it. That's all they can be. It's a fixed way. Whereas a mixture can be together in a variety of different ways. They can have a whole bunch of different ways that we go together. All right, so they have a variety. All right, some elements. Again, remember, elements are on the periodic table. It's an element if it cannot be broken down into anything simpler. Elements contain one type of atom. So then the question I always get is, well, does that mean all of the atoms are the same? No, remember, all it's saying is each individual element has one type of atom. So atoms of copper are not the same as atoms of oxygen. So the atoms here in the little copper penny are not the same as the atoms in the balloon. Okay? They're two completely different things. Next thing we're going to look at then are our compounds. A compound, remember, is a substance that contains two or more elements bonded together in a constant or fixed composition. So this little, rock salt down here always contains one sodium, one chlorine. It has to. Now that pattern repeats over and over and over again, but the fundamental compound contains one Na and one Cl. Remember that these things mean they're always going to be hooked exactly the same. So if the formula is Na3Cl5, it's something completely different than something that's just NaCl. Salt, the way we know it, has to be this. There's no other option. Remember that the properties of compounds are different than those of the elements that make them up. Sodium is a silvery kind of metal. It's kind of soft. Chlorine is a noxious, awful, yellow, kind of palish green gas. You stick them together, you get salt. Kind of as an essential thing. We need salt in our diet. Water is another great example. Hydrogen is flammable, oxygen supports burning, but water usually puts out fires. The smallest part of a compound, that one little repeating pattern, is called a molecule. Right? Mixtures, the last of our types of matter. Mixture is going to contain two or more elements, kind of like a compound, except they are not going to be bonded together and can have variable composition. So these things, the great examples are things like Chex Mix, trail mix, etc. Things where you can see all the little different pieces in there and you can say, oh, well, they're not bonded together. I could just move them away from each other. Remember, again, mixtures do not bond together. They can be all sorts of various ways. Now, the tricky part is that we boil down to there are two types of mixtures. Because there's so many different kinds, we have to kind of break them up. So a heterogeneous mixture is one that does not going to look even or the same throughout. These, again, are ones where you can see the individual parts. Examples, trail mix, Chex Mix, granite. Beach sand is an okay example if you're talking about like the beach sand in Iowa. Because you go pick a handful up off of the riverbank, and it looks pretty different throughout. You got sand, you got mud, you got all sorts of other stuff. So for example, over here in kind of our mix of dried fruit and peanuts and whatever, you can see the individual parts. So right here, I got a peanut. Right here, I got a raisin. Over here, I've got an almond, etc. You got a banana chip. You can see all the individual parts. Versus a homogeneous mixture. In steel down here, I can't see what's iron and what's carbon. I don't know. These things are going to look even throughout. So therefore, we call them a homogeneous mixture. Remember, the prefix is hetero, meaning different, homo, meaning the same. So a homogeneous mixture is going to look the same throughout. We call these things solutions. Now that gets a little confusing because people think the solution has to be in a liquid state. Well, this over here, this steel, that's what this stuff is technically a solution. It's a solution where iron and carbon are dissolved in each other. They can exist in any state of matter. The specific case that we're looking at here is a mixture of two or more metals put together. We've got iron, we get carbon, we have an alloy. An alloy, again, is a specific case of two or more metals being put together. All right? Some examples again are tap water, steel, milk. Your milk you're familiar with would be homogeneous. All right? So what I'd like you to do is to kind of come up with, for a second, pause the video, look at your list, and tell me which of the following things you think are elements, which ones do you think are compounds, which ones are homogeneous or solution, and then which ones do you think are heterogeneous. So go ahead and pause your video for a second, and on your packet you have an example of an element, compound, heterogeneous, homogeneous. See if you can put the correct ones in the correct spots. Alright, so took a second hopefully and went back and looked. We'll go through and kind of classify these really quickly. Kool-Aid would be a solution or homogeneous. Calcium carbonate, you see how you have a formula here. CaCO3, that's telling you you have these elements bonded together. That makes this a compound. Brass, in case you don't know what brass is, it's a mixture of tin, which is the chemical symbol Sn, and then usually some iron, possibly copper. So this is specifically an alloy, which we said could be classified as a solution. Copper, if you've looked it up on a periodic table, copper would be an element. It is listed on our periodic table. And then hopefully everybody sees, checks mix. The mix is right there, so you know it's either got to be heterogeneous or homogeneous, and hopefully you understand. I can see the pieces, therefore heterogeneous. Okay, so the last thing that we're going to do really quick is I'm going to kind of show you kind of a little chart for how I would set this up and how to understand the difference and kind of how to separate these things. So give me 1 second and we will go through and draw a chart real quick. Okay, so to separate matter, again, we're going to start up at the very top with, let's say we have all of our matter. It's going to split off, remember, into 3 distinct parts. And you don't have to copy this down if you don't want to, but hopefully it'll kind of help out a little bit. Remember our 3 types are elements, compounds, and mixtures. Sorry, that got a little messed up there. Mixtures then split into homogeneous and heterogeneous. All right? Homogeneous things look the same throughout, where heterogeneous things, remember, look different. Usually the toughest thing to tell apart then is elements or compounds. Elements, remember, must be on the periodic table. If they're not there, they're not an element. And a compound has to have a formula. So something like water, for example. Alright, so what we want to make sure that you do then is go ahead and finish up. Make sure you have an example at least of one of each different thing. Answer the last couple of questions under your notes, and then you will have an assignment on Schoology. So make sure when you finish with your notes, go ahead and you should have an assignment called Classifying Matter.